Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yeah, so hello everyone. Am I properly audible and visible? Can anyone please confirm that in the chat box? And let's see how many students have arrived. Yeah, I would request everyone who are watching me right now to kindly write their name in the chat box or just do a +1 so that I can get to see their names who all are attending just to confirm your presence. So, hello Rishit, how are you? Yeah, thank you, Rishit. Yeah, so I would request the other students as well to kindly do the same and I can very quickly start then. Hello, Anil Chandra. How are you? Yeah, I am great as well. So I'm sure that every one of you all know about this present series that is going on right now. Yeah. So the series is named as Session for SDE Interview Preparations, and the series that we are presently doing is focusing upon improving and practicing about interview questions. Okay, so we started this series last week, I suppose, and in the first week we did 3 sessions on binary search. So we implemented questions related to binary search. Give me a minute. Yeah, apology for the. Yeah, hello everyone. I am sure that I am properly audible and visible. Yeah, a small apology for the background noise. So we can continue with our discussion. So I am sharing my screen. Give me a minute. Yeah, so I suppose my screen is properly visible to everyone. Can I please have a small confirmation in the chat box so that I can continue with my discussion? Yeah, so today we will be discussing about bits manipulation, and let me tell you a small introduction about our series. So we are having a series called as practice session for SDE interviews, which we started in last week. And in the first week, we covered binary search. In fact, we took three sessions on binary search. The problems were mostly on binary search and answers. We did few famous problems like allocating minimum number of pages to a book, aggressive cows problem. Then we also, I also gave you all the pointers necessary for the interview preparation related to binary search. So today we will be mostly focusing on bits manipulation today and tomorrow. Okay, so let us start then. So yeah, apart from that, I would like to request you all that since this series is focusing upon interview preparation practice, I would recommend you to kindly watch it live on a regular basis. Apart from that, we are also having a dynamic programming series going on Thursdays and Fridays, and we also have a live mock PSA session on every Saturday at 10 p.m. So if you're preparing for your interviews and you would like your mock interview to get scheduled with any of the mentors at Geeks for Geeks, you can just fill out that form in the description. Okay, so this is the entire week's plan that happens every week on this particular channel. And we would recommend you all to kindly give your own recommendations as well of what you all want, what the audience wants. Okay, so in that case, we can plan out such content as well. Okay, I hope this is clear. Hello, Anil Chandra. Hello, Rishit. Hello. Yeah, no worries. Yeah, apart from that, there is one more thing. You will find a link in that is pinned with the first comment of the streaming. That link is particularly about the course called Complete Interview Preparation. So, if you're preparing for your interviews, I would highly recommend you to kindly check out that particular course. Okay, it contains everything, all the necessary important topics, all the frequently asked problems, the important topics, and the concepts which are very frequently asked in interviews of most of the product-based companies. So I would recommend you all to kindly have a look at that course, and that would very be fruitful in your preparation. Okay. So with that being said, let us start with bits manipulation. So I'm sure that everyone knows about bits manipulation because I'm assuming that you all are particularly doing your preparation since a long time. Okay. So the purpose of this session is to give you a practice to the frequently asked questions. Can anyone tell me? Let me just. Everyone knows about the basic XOR operation and the basic AND and the basic OR operation, the bits operation. So there are three types of bits operation. The first is the AND operation, then we have the OR operation, and then we have the XOR operation. Okay, so these are the three types of operation that are very particularly known. Yeah. So can anyone tell me? Um, can anyone tell me that whether XOR is commutative or not? Yeah. Anyone? Okay, so Rishit is asking for recommendation on system design content as well. Okay, Rishit, we are actually planning about providing system design content as well. So you will see a notice very soon about that. Okay, some other mentor will probably be planning a system design streaming as well. Okay, so this was about Rishit. So does anyone know about these three basic bits operation. So first we have the bitwise AND operation. So what happens in bitwise AND is that the truth table will look something like this. That if both the values are 1 and 1, then only it will be, the output will be 1. And in case if any of them is 0, the output will be 0. Okay. So if one is 0 and 1, the output will be 0. And if the other is 1 and 0, the output will be still 0. And if both are 0, the output will be 0. For bitwise OR, I know that everyone knows about bitwise OR, that it will be 1 if either of them is 1, and it will be 0 only if both are 0. But the most important of these three bits operation is the XOR property. Okay, the, pro- the property of XOR is very important. So basically, let's say that XOR is basically you add both the bits and do a mod 2. Okay, so let's say you got two places, and so what you do, you add the bits at both the positions, and you do a modulus to 2. So if both the position contains 1, in that case what will happen? 1 plus 1 equal to 2, and 2 mod 2 will be equal to 0. So if both the positions are 1, or if both the positions are 0, in that case you will get a XOR is equal to 0. And if either of them is 1, like 0 1 or 1 and 0, in that case you will get your XOR as 1. Okay, so this is the concept about XOR. Okay. Now, in fact, most of the interview questions that we will be doing, and in fact, what are asked these days, involves mostly about XOR properties. XOR has a lot of wide variety of properties. So the next thing that we will look into, what are the properties and important tactics related to XOR. So can anyone tell me what will happen if I try to XOR a particular number, let's say n, with the number itself? In that case, what will happen? Anyone? Yeah, it will become 0. Yes. Yes. And tell me what will happen if I try to XOR a number with 1. So given number n, and I'm trying to XOR it with 1. So what will happen? Yes, the answer will be 1 in this case. So can anyone tell me an expression that will involve two numbers, a and b, um, an expression involving a XOR b in terms of a and b? Can anyone tell me? An expression involving a XOR b in terms of a and b. Maybe I actually asked a difficult question. You may not know this property very well. So anyone you can try how you will represent the A's or B in terms of A and B. Okay, Rishit, just a minute. So let's say you are given a number n which contains a lot of bits, and 1 will basically be the last number. Okay, so and every number is equal to 0. So in that case, what is happening here? Okay, I made a small mistake here, so this won't be like it. Yeah. So what I was trying to ask is what will happen if you are trying to XOR it with 0. Okay, any given number you are trying to XOR it with 0, not with 1. Apology here. So what will happen if you're trying to XOR a particular number n with 0? So you can just do the same operation here. Try to put the number of bits, and 0 will be equivalent to all the bits positions are occupied with 0. So try to do the XOR, and in that case you will see the result. N XOR 0 will be equal to n. Yes. Yeah. So these are the two important properties that I wanted to highlight, is that whenever you are XORing two numbers which are same, the answer is 1. And if you're XORing any number with 0, the answer is equal to n. Okay, so this was about the XOR properties. And can you even tell me that how can you represent, let's say you are given two numbers and I'm asking you to represent A XOR B in terms of A and B. Okay, can anyone try this out? This is actually a very famous inequality, you can call it, and these are widely used in maths, in fact. So, but many times online assessment questions are usually based upon this trick. Okay, so basically, if you see this that we can represent A XOR B. Okay, A XOR B can be represented like something like this in terms of A and B. It will be equal to A plus B minus 2 into A and B. Or we can represent A plus B equal to A XOR B plus 2 into A and B. Okay, so this is how it gets represented. So let me write that equation here. So the equation will look something like this. A plus B is equal to A XOR B plus 2 into A and B. Okay, so this is how the equation looks, and you can write A XOR B is equal to A plus B minus 2 into A and B. So basically you can do this operation. So how is this getting derived? If you try to just do this operation, you will understand basically. Okay, so what happens in A XOR B basically, let's say what exactly is happening in A XOR B. So there are two numbers A and B and you're trying to XOR them. Okay, so XORing basically means that in the XOR value, those indexes will be 1, in which either both the numbers are 1, or either of them is equal to 1. So if there is 1 here and 0 here, or 0 here and 1 here, in that case, that particular bit will be 1 in A or B. Okay, so A or B will basically give rise to 2 to the power I. For every bit that is set in A or B, you will get a 2 to the power I in that case. And yeah. So, and what happens in A plus B basically is that, uh, and whenever you are multiplying A and B, so A and B will give 2 to the power I in those cases only if both are equal to 1. So if you add these two values, you will get A plus B. Okay, so if you just try out writing all the truth tables and try get the results, you will see that this expression always holds true. Okay, so this was one of the difficult property that I wanted to explain. So please make a note of this. I hope everyone is noting it down. And can anyone tell me in comments, did you know about this expression beforehand? I'm sure you must not be knowing this. Yeah, hello Naikash, how are you? You are present today. Hello Udipta, hello Utkarsh, hello Gautam. So Naikash, did you know about this expression? Yeah. Yeah, so please have a note of this expression. This may come handy while you're trying to solve any particular question, which may involve addition, XOR, and the AND operation. Okay. So mostly you will find questions involving bits manipulation can be done if you are trying to just write everything in form of XOR or AND. Okay. So let's say if you are adding two numbers and you want that to do it in the view of bits. So what you can do, instead of just writing A plus B, instead write A XOR B plus 2 into A and B. Okay. So you can do this operation in terms of bits. So one question, to prove this inequality, we can interpret that set bits of the numbers in the form of 2 to the power I, right? Yeah. So, okay, let me just prove it all for you. So see, let's say that in case A is a set bit at any particular position, A is a set bit and B is an unset bit. So in that case, A or B will be 1. So the resultant of A or B is a set bit. Now what happens in A of I? So in A and I, what happens basically is that if one is set and the other is not set, A and B will give 0. So it is not contributing to anything. Okay. But what happens in A plus B? Let's say if A is 1 and B is 0, it will contribute 2 to the power I in that case. So let's see. This is contributing 2 to the power I. This is contributing 2 to the power I. This is contributing 0. In the case when either of them is 1 and the other is 0. Okay. Now what will happen if both are 1? In case if both are 1, this part will become 0 and a and b will become 1, but this will give 2 times 2 to the power I. And the same thing happens in a plus b, because uh, at ith position a is set and at the ith position b is set. So this is giving 2 times a2 to the power I. So you see the inequality is holding on both sides. The idea of addition, so whenever you are trying to add two numbers, if the both the bits are set, it is contributing 2 to the power I to the answer, right? So so let's say if you're trying to add 4 plus 4 it will become 8. Why it is becoming 8? 2 to the power 2 plus 2 to the power 2. The second bit is set in this number and the second bit is also set in this number. So both are contributing to the overall sum. Okay. So this was the idea. Okay. There are no formal proofs about this. You just have to see that the concept, what exactly the concept of addition is doing, what exactly the concept of XOR is doing, and what exactly the concept of AND is doing. Got it, Rishit? What I just tried to explain. Yeah, thank you. That's great, Rishit. I hope the intuition about this is very clear. So this was one of the tough inequalities that I want, expression that I wanted you all to know today. Apart from that, the rest of the stuff will be easy today. Yeah. So let's move on to the first problem that we want. Basically, involving understanding bit manipulation is basically having a proper sound knowledge of mathematics also. So majority of the question would be involving observation about the bits places. So you need to be good with that. Okay. So I'm giving you a link of the collection of articles on Geeks for Geeks. Try to have a read about all the articles. Okay. I will be discussing a few of them in this session. Definitely, I cannot discuss all the sessions, all the articles. There are around 20-25 articles present here. Okay, but I will be discussing the important ones. So let's have a look at here. So this the first point. This is like computing XOR from 1 to n. So this is one of the very famous things that you will learn the very first time you are trying to learn bits manipulation, as to what is the XOR, cumulative XOR of all the numbers from 1 to any given number n. So what you do, can anyone tell me the pattern if they know? So there is a very interesting pattern that is usually observed in this case, and based on that pattern, we try to form our answer. Okay, so this is the pattern exactly, and if you try to just write the XOR of something like this, you write the XOR of 1, which will be equal to 1. Then you do XOR of 1 XOR 2, 1 XOR 3, 1 XOR 2 XOR 3. Then again 1 XOR 2 XOR 3 XOR 4. Just try to write cumulative XOR in a piece of paper, and then you will see the observation that the same pattern is getting repeated every four numbers. For x equal to 0, 1, 2, and 3, this pattern will get repeated for every numbers from 0 to 3, 4 to 7, something like that. Okay, so this is basically observing the pattern it is being formed and then deriving a formula based on that. So yeah, so in this case, I won't be spending much time on this because I'm sure everyone knows about this. So if x is equal to 0, the answer would be n. If x is equal to 1, the answer would be 1. If x is equal to 2, the answer would be n plus 1. And if x is equal to 3, the answer would be 0. So you can just write a small function which is implementing this exact same concept. Apart from that, let's have a look into here. So let's say you want to count the number of numbers smaller than or equal to n such that n plus x is equal to n XOR x. Okay, so how many numbers are there x such that when the addition of a number n with x is equal to n XOR x? Okay, how will you do this? So basically, I just gave you an expression, right? A plus b is equal to a XOR b plus 2 times a and b. Just try to utilize that expression and solve this question. And this will be basically a special case of that particular expression. Rishit, can you solve this? The expression was, I'm writing it again, a plus b is equal to a XOR b plus 2 into a and b. Now, the question was saying that n plus x is equal to n XOR x. Okay, now you have to find the count of x, that how many such numbers x are there. Okay, count of x. So this was the funda behind it. So how will you utilize this expression to derive to find an answer to this? Can anyone tell me? So n and x must be 0, right? Yes, it should be 0. So what do you understand if n and x are equal to 0? N and x. So and of two numbers will be 0. When does an and of two numbers become equal to 0? Just try to think and come up with the answer. Rishit, tell me. Naika is saying that n natural sum. Both don't have set bits at same position. Hmm, exactly. So if n and x is equal to 0, and x is equal to 0, it means that in both of the n and x, you will not find the set bits at the same time. So it means that if there is a set bit at n, it should be the set bit should that particular position in x should be equal to 0. Okay. So this is the so if let's say if in n we have a 0, in this case it can either be 0 or it can either be 1. Okay, it doesn't matter. Okay, but if it is 1, it should be equal to 0. And if it is 0, it can either be 1 or it can either be mm, 0. Okay, so and when you do the and of all the numbers, you will get x. Okay, so this is n and this is x. So how do you know that? How will you tell me that how many different types of x's exist? You have to apply just a small concept of permutation and combination, and you will get the number of different types of x's that can exist. So let me tell you that since if it is equal to 1 in place in n, so for our x it is fixed that it will be 0. Okay. So what is basically happening? So if the number is equal to 0 in n, at that position it can either have 0 or it can either have 1. So what you will yeah, Rishit is writing for every each bit where n has 1, we can only have one choice, that is 0. For each bit where n has 0, we will have two choices, 0 and 1. So 2 to the power unset bits of n. Exactly. This will be the answer. Hmm. As you can see, in the article is also written the count will be 2 to the power the count of 0 bits. Okay. And can anyone tell me how C++ implemented function which will help you get the count of all the 0 bits, unset bits? There exists a function in C++ that will help you just count this number of bits. You don't have to write a loop or anything. Just take that function, give the value, the number which you're trying to find, and it will just return that value. And there are similar function for counting the number of ones as well, the number of set bits. Can anyone tell those functions in the chat box? And then we are continuing with our question. Okay, let's see then. Let us proceed further. So then the third tactic, it is mentioning how to know if a number is a power of 2 or not. In this case also, you will be able to solve it. If a number is a power of 2, then the bitwise AND of n and n minus 1 will be equal to 0. But this will not work if n is equal to 0. So just check these two conditions. And if any of these conditions is true, you will know. So what is the intuition behind this statement? Okay, so the intuition basically will be, let's say n is a power of 2. In that case, the very first bit, that is the most significant bit of that number, will be equal to 1. And all the remaining numbers will be equal to 0. But when you do an n minus 1, you decrease 1 from the given number, it becomes that the position in which n was set, that is the most significant bit of n, will become 0 in n minus 1, and all the remaining bits will become 1, because that is the difference between a number which is at the power of 2 and which is 1 less than the power of 2. So, if for example, 16 will be equal to 1 and 3 times 0, but 15 will be equal to 0 and 3 times 1. Okay, so this is how the difference between both the numbers. And when you are doing as or bitwise and of these two numbers, since for every position you are seeing that it is either 1 or 0 in both the cases. So the bitwise or will be bitwise and will become 0. So this is how you check that whether a number is a power of 2 or not. Quite straight and simple. So any questions here? Yeah, I see we have around 10 people live with me right now. So let me tell you that we are having this. Sure, Rishid, I'm telling you about this. So let me tell you about this series. So we are having this particular series for preparation for SDE interviews. And if you're preparing for your interviews, attending this series will be very helpful. I would request you all to kindly invite your other friends and other colleagues for watching this series as well. Apart from that, we also have a complete interview preparation course, with the link of which is in the description of this chat. You can definitely check that out. It is an extremely well crafted course, specifically targeted for improving your practice and your skills for clearing the interviews. Okay, so it contains all the important concepts, all the frequently asked problems, which you should know at your fingertips, are all included in that course. So definitely check that out. The link is also pinned on the very first comment of this stream. So let us move to the next part. Yeah. So Rishit was asking that. Let me share the function. So there is a function called built-in pop count, which basically will give you the number of set bits. Okay. So there is another similar kind of function. I don't remember the name. Let me Google. Uh, uh, function function to count unset bit. Okay. So let's see that. Yeah, Naika is saying how many necessary bits in any number that how we can find. How many necessary bits? I don't understand. Like, what do you mean by how many necessary bits? Can you please elaborate your? Yeah. So as I told to that there is a function called underscore underscore built-in pop count. So that function, whatever number you will set, it will return the number of set bits. To form a number, there are 32 bits now. Yes, yes. So if a number is an integer, in that case, you will see an integer basically allocates 32 bits 32 bits for any particular number. So you will see that a number will have 32 bits. So the maximum number you can get is 2 to the power 32 minus 1. Okay. So this is the concept behind an integer data type. But if you are having a number which is of long, in that case you will have 2 to the power 64. There will be 64 bits position in that case. So this is the number. Mhm. But if it is, you just have to make sure that what is the data type. Okay. So let's see what this article is saying. Uh, Counting the set bits. There is something called built-in pop count. I am unable to find the name. Let's move then. You can just try to Google about more about built-in functions. Okay, so let us proceed to the next part. Now you can read about this finding the XOR of all subsets of a set, and then you can also read about finding the number of leading, trailing, and the number of ones in this case. This is a number. Okay, so built-in pop count will give you the number of ones. So after you get the number of set bits, you can just subtract the total number of bits from it. You will get the number of unset bit in that case. Then there is something called built-in CTZ. It will give you the number of trailing zeros, and built-in CLZ. It will give you the number of leading zeros. So these functions are actually handy. Hmm. So basically, I was thinking that there is a function in GCC compiler that will help you return the number of unset bits. Okay, so I'm unable to find that. Built-in pop count is giving you the number of set bits. That is the number of ones present in a bit. So you just do a 32 minus the number of ones, you will get the number of unset bit in that case. If your data type is an integer. Okay, so this that I want meant to say. Hmm. So now let us look into the problem that we were supposed to do today. Okay, so the problem is I want to say the number is 4, then the number of bits is 1000. Yes, the number of bits is 1000, but the number 4, let's say you are declaring the number as an integer. Okay, you are writing int a equal to 4. So the compiler is allocating 32 places of bits for the number 4. So it happens that the index at 0 is equal to 0, second is also 0, third is also 0, fourth is 1. So the index at basically the index number 3, it is a set bit. All the remaining are 0. So it doesn't mean that there are only 4 bits. Okay, the compiler is allocating in 32 places, but out of the 32 places, you are seeing that at the position number 3, you are finding a 1, and all the remaining positions are basically 0. Okay, this is what I was trying to say. But since up till here, the idea of a number is ending, so we just keep it simple. So how can we count it? Like you want to count the number of So so that is the reason basically that doesn't exist a function that you will count the number of unset bits. Hmm. So if let's say if you just put a built-in pop count, this will give you equal to 1. So if you do a 32 minus 1 equal to 30, so this says that int a equal to 4, a contains 30 places in which the bit is not set, bit is equal to 0. Okay, so this was the concept here. Okay, so hmm. But if you're considering a equal to 4, just let us say that there are 3 unset bits because 4 is up till here only. Okay, so that is kind of a fallacy in our understanding. So this is about. Hmm. So apart from that, let us do the problem that we were supposed to do today. So let's say you are given two numbers. You're given a array of size n, and that array contains all the occurrences of a number in even number of times. And there are only two numbers which are occurring odd number of times. So you have to find those two numbers. Okay. So let's say if the size of the array is 8 and the numbers are 4, 2, 4, 5, 2, 3, 3, and 1, you see that the number 5 is occurring once and the number 1 is occurring once, which is having odd occurrences. So you output 5 and 1. Okay, so this is exactly what you have to do. So how will you do this? Can anyone just briefly write the concept about solving it? This also involves OR, and this is actually a very famous problem. You see, around 30,000 people have solved this problem. XOR all elements, yes, this is the first step, but this will not give you all the answer. So what will happen when you will XOR all the elements? So let's say you have elements A. So the elements which are occurring in even number of times, if you try to XOR those elements will become 0. Okay. Yes. So what about the number those are occurring odd number of times? Anyone apart from Nikos? Hmm. Yeah, you will be left with the XOR of the two odd numbers. So let us say that the two numbers which are occurring odd number of times are A and B. Okay. So the first time you XOR all the elements, let's say you get a value called K. So in that case, A XOR B will be equal to K. Okay. So this problem can also be solved in a brute force way, but since we are doing a bits manipulation, we are actually taking care of doing it with the help of bits. Okay. So basically, the same problem can be done with the help of maps as well. Okay. So you store all the elements in the map and increase the counter, and if the counter is equal to an odd number, in that case, what you do, you just print that element, or that will be included in your answer. The time complexity of this approach will be big O of n log n. Okay, because you are implementing the concept with a map. Okay, so that is the why the login part is coming. But now, if you want to optimize this further to only a linear time complexity, you have to use the concept of bits manipulation. Okay, so let's say A and B are the two numbers which are occurring odd number of times. So the first thing that we can do here is that we will write A or B is equal to K. So yeah, now this is basically not giving us any valid um, conclusion. So what we can do? We have to again. Can anyone just briefly describe me what should be my next steps of action so that I can solve this problem? So we have around 9 people live with me right now. So I already told you about the complete interview preparation. So we also have a mock interview session, which is usually done on Saturday at 10 p.m. So if you are preparing for your interviews and you would like to have your mock interview scheduled with any of the mentors here at Geeks for Geeks, you can sign up our form and we will get it scheduled for you. Yeah. So what I want you all to think is basically, let's say that you XORed all the numbers and you got a value k which is equal to a XOR b. Now, when will what the conditions will be that k is a set bit? Okay. So let's say a particular bit is set in k. It means that it is either set in a or it is either set in b. Okay. It cannot be set in both the ways. So what you do basically, you take a particular position of bit and you see whether it is set in k or not. If it is set in k, then it means that A is set or either A is set or B is set. Any one of them is set. So what you do basically is that you try to divide the entire group into two parts. The first part will contain those elements in which, in that position, the particular element, particular bit is set, and the next part of group will contain those elements in which, at that particular position, those are unset. So in this way, what will happen? The two numbers which are occurring odd number of times will basically go in two different groups. A will go in the first group and B will go in the second group. Like this, the intuition is like this. So now what will happen, since both the odd occurring times are divided into two groups, you can now XOR both the groups respectively. So if you XOR the first group, since all the even occurring will get cancelled, you will be left with A, which is the odd occurring time. And you can print that. And when you XOR the second group, all the even occurring elements will get cancelled and you will be left with B. So finally you can return A and B together. So this is the idea of idea about how you will XOR the elements so as to get the number, those two particular elements which are occurring odd number of times. Okay. So, did anyone understand the intuition properly about how we are using this? Naikaj, Rishit? Yes, yes, Rishit, I'm doing a dry run as well. So, let's say what we do basically. The first step would be to XOR all the numbers from A to I. Now, uh, now what the next step is to get any one of the position, get one set bit in XOR2. XOR2 is a variable. We can get the rightmost set bit in the following line as it is easy to get. So this expression XOR2 and you are doing not of XOR2 minus 1. In this case, it is getting you that particular position number, which is the first set bit from its right side. So you get that particular position. Now what you have to do basically, you have to divide the element into two sets. The elements having corresponding bit as 1 and the elements having corresponding bit as 0. So XOR of the first set is finally going to hold one of the particular elements. So basically, error of I and you will do the set bit number. So it means that if that particular bit is set, you do a XOR in the variable x, and if not, you do a XOR in variable y. So what will finally happen? The x and y will become the two numbers which you are trying to output. Now, since the question is saying that you have to output a vector, the first element should be greater than the second. So you push back the first element is the maximum of x and y, and the next element you push back is the minimum of x and y. And then you can finally return the. Okay, Rishit. Rishit, let me do a dry run for you. So let's say in this case 4245233. So once you XOR all these numbers, you will be left with 5 XOR 1. Okay, because 5 and 1 are occurring odd number of times. So 5 XOR 1 will be how much? So let's do 5 XOR 1. So 5 is equal to 101. Okay. Hmm. This is 5 and 1 is equal to this. So when you do a XOR, this will become 0, this will become 0, and this will become 1. So 5 XOR 1 is equal to 4. Okay. Now this is the value of the key that I was talking about. Now what you do, you check for the rightmost set bit. In this case, the rightmost set bit is at position number 2. Now you see all the numbers which are having position number 2 as set and position number 2 as unset. You put all the numbers which are in position which are having position number 2 as set in one particular group, and all the numbers which are having position number 2 as unset in another particular group. In that case, what will happen? A will fall into the first group and B will fall into the second group, because this is A and this is B. So now this A, which was occurring odd number of times, is actually in this particular group, and the number of B, which is occurring odd number of times, is actually in this particular group, and the rest of the numbers will be occurring even number of times. So when you XOR this group and you XOR these groups, the number which is remaining is A, and the number which is remaining is B. So now you can output that. This was not a hard question. Actually, this was actually a very easy question. This was based upon the fact that property of XOR. So it may either be that you do not know this property of XOR. In that case, it would look tough. So initially, I discussed this property of XOR, and then I just jumped to this problem. Okay, so what you have to do is get a hold of your basics, learn all the properties of XOR, and then come and try to do the problem. Okay, so this was based upon this particular property. Would any set bit work from the XOR of the two numbers? Yes, any set bit. Yeah. So actually, it was very easy to find the rightmost set bit, but any set bit. You just have to find any particular position which is set in the number A or B, and for only that particular position, only try to divide into two groups. Okay. So, but it is very easy to get the rightmost set bit just in O of one operation. So that was the reason I was speaking about rightmost set bit, but it can be any bits. Okay. Yeah. So this was about today. Yeah, thank you. Welcome, Rishit. I hope that everything got clear. So this is another question that I wanted to do, but due to the paucity of time, I'm not able to do this. So this will be for a homework for you, and we will be discussing about it tomorrow. Okay. So I'm putting the link in the chat box, and you can just have a look at it. This is actually a simple problem again. You have to find the XOR from the range of L to R. Okay, I will give you a hint. So during the beginning of this session, we discussed about a formula about a particular pattern of consecutive XORs from number 1 to n. Okay, so let's say you want to find a XOR from L to R. So what you will do, you will find a XOR from 1 to R, and you will find a XOR from 1 to L minus 1. So you got these two XORs. Now in order to get a XOR from L to R, what you do basically, you just XOR both these numbers together again. So all the numbers will basically get cancelled from 1 to L minus 1, and whatever number is remaining, it will be your answer. Okay, so you just have to find for the number R and for the number L minus 1, solve both the numbers together, and you will get your answer. Okay, so that is the reason this question is marked as in easy category, because it is a direct implementation of the formula that we discussed, and you can do that in O of one time. Okay, yeah, so this was about today. um, I hope everyone got an idea about today's session. So yeah, so let us meet tomorrow then. We will again be discussing a few concepts about bits manipulation, which are very important from interview point of view. Yeah. Apart from that, those who joined late in the session, we are having this session on every Mondays, Tuesdays, and Wednesdays at 9 p.m. This session is specifically focusing upon interview preparation practice. Apart from that, we also have a dynamic programming session going on Thursdays and Friday, and a live interview session on every Saturday. Okay. Yeah, this is very similar to finding a sum in a range L2R with a prefix sum array. Yes, exactly. But the concept is same, but in this case, you have to do it in terms of bit manipulation. Okay, so this is where the concept and logic arrives here. I hope everyone will be able to solve this question. Okay, anyway, let's meet tomorrow then.